Hi, I'm Abigail. This is Surya and this is Rajesh. We are from SSN College of Engineering, Department of Biomedical Engineering. We are presenting our project for Texas Instruments Analog Design Contest 2014. Our project title is Silent Speech Recognition System using EMG. Our team ID is 75.3 and CMD number is 107. Silent Speech Recognition System using EMG is a communication aid for people with speech disorders such as dysphonia and dysarthria. Dysarthria is a condition in which a person has slurred speech, and dysphonia is a condition in which a person has vocal cord spasms which are continuous and repetitive. It can also be used for people who have lost their speech accidentally, but they must have excellent laryngeal muscle activation. The most interesting scenario of our project is the communication is done only with the laryngeal muscle activation without any discharge of sound.
Now we are going to discuss about the hardware that's involved in the system. In the hardware, the first stage of hardware is amplifier. The amplification of the signal is done in two stages. First stage of amplification is done by using INA128 instrumentation amplifier manufactured by Texas Instruments. The second stage of amplification is done by using LM324, which is also a Texas Instruments manufactured IC. Thirdly, we are using C2000 Piccolo launchpad. And Piccolo launchpad is followed by LED driving circuit, which is using ULN 2003. These are the two inputs that's given to this impedance matching circuit, and the impedance matching circuit is connected to INA128 instrumentation amplifier. This is the gain resistor of 500, and it is connected to that right driven leg amplifier, which is LF356, which is used to reduce the common mode interference. And this is the filter we used IC LM324, which is active band pass second order butterworth filter of gain 10, which is used to filter out the necessary signal. And this is the notch filter that's used to remove the power line interferences. And this is the finally batteries that's used to drive the entire system. And without the batteries, the circuit can't function. And here is the National Instruments data acquisition card. The output of the circuit is given to the analog input of the National Instruments DAC. It is processed. The National Instruments DAC consists of analog pins through which it's connected to the system, and the signal that's taken from the DAC is processed in the lab view, and the person will get modified to the word that he intends to produce, and the output of that lab view is given to the C2000 Piccolo launchpad, and the C2000 Piccolo launchpad is used to drive the entire LED driving external systems. And here we have to check the jumper pins and the analog input and output pins in order to make the Piccolo launchpad to function well. And the output is given to the ULN 2003, and these three LEDs are just the indicators. These are the two reference electrodes. These are the bipolar electrodes that's used for making EMG, and this is the ground electrode that's placed in the mastoid bone. And these electrodes are used for picking the EMG signal. These are actually the biopack electrodes, AGCL electrodes. And the electrodes are connected to the circuit here. And the circuit will take part of the amplification and the filtering of signal. And the output of the circuit is given to the National Instruments lab view. This is the data acquisition card. You can able to see the analog input pins that come from the output of the circuit. And the National Instruments data acquisition card is connected to the system through the lab view. Actually, this is the recorded EMG of the muscle activity in the larynx region. You can see this is the contraction of the muscles, and this is the noise that's obtained during acquisition of the EMG. You can see the contraction period. This is the contraction period. This is the relaxation periods, and this is the EMG that's obtained due to the muscle activity. Now the person will pronounce the word right without any voice or sound. Now the person will pronounce the word go without any sound or voice produced. Now at last he will pronounce the word left without any voice or sound produced. Now when the person tends to say the word without any voice or sound, it will be displayed by the external LED driving system and the corresponding artificial voice will be generated.
Right.
The glowing of the right LED denotes that the person tends to say the word right.
Go.
And the glowing of the go LED denotes that he tends to say the word go. The entire system is driven by the Piccolo 2000 launchpad.
So far, we have done communication using wire medium for various control applications. It can also be transmitted using telemetry. The various applications of our project are navigation control for paralytic patients, gaming control, secret communication, and other robotic controls. Thus, our project is very useful for the speech disordered people to lead a happy, independent life. It was indeed a great opportunity for us. Thanks for watching.